A percentile is a number that describes the percent of data below that value. And if it describes the percent of data below that value, it's pretty easy to describe the percent of data above the value. The 20th percentile, for example, tells us that 20% of the data lies below that number. Now, the 20th percentile number is a value that's associated with some data set. For example, suppose we're thinking about SAT scores, and we say that a 1300 on the SAT is at the 70th percentile. Well, that tells us that 70% of the SAT scores are below 1300. Also means that 30% are above 1300. So let's see, now 60 percentile, the 60th percentile would tell us that 60% of the data is below that value, 40% is above that value. But that's all that percentile is doing for us. It's just telling us, it's a number that tells us the percent of data lying below that number, and then we can figure out the percent of data lying above that number as well. The notion of quartile is related to percentile. Quartile numbers sort of subdivide the data set into quartiles. And if we have subdivided our data set into 25% in this range and 25% here, 25% here, 25% here, then the first quartile number would be this Q1. That's what Q1 stands for, is the first quartile number. It means that 25% of the data lies below that number. And then we can also figure out that 75% must lie above that number. Now this number, this Q1, this first quartile number, is also the 25th percentile, because 25% of the values lie below that number. So the same value that is the first quartile number is also the 25th percentile number. The second quartile number, the second quartile, if we're talking quarters now, the second quarter is 50%. And so that's in this position, that would be the 50th percentile, and that number is the median. The third quartile number, 75% of the data lies below that value, and that would be the 75th percentile. Let's talk about how to set up quartiles. We have to first arrange the information, and then we're setting it up into quarters, and the easy way to do that, I think, is to divide the data in half and then divide the halves in half. Let me show you what I mean. Here we have a number of numbers, and they're sort of randomly assembled right here. We need to assemble these in an ordered fashion, lowest to highest, and so I've done that here. 84, 85, 86, 88, 89, 89, 89 appears twice, you see, 90, 96, 96, and 100. All right, we first identified the median. The median would be the second quartile value, and let's see, since we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values, then the median is between the 5th and 6th. You see, because the median is a number that gives us as many data values above as below that number. So let's see, 1, 2, 3, 4, 5, and here's the 6th. So it's between the 5th and 6th. Oh, the average or the mean of 89 and 89 would be, 89. So this then would be the median. Also the second quartile number, and the value is 89. Now, from that position, we'll take half of, or find the median for this group, and then the median for that group. And the median, let's see, we have 1, 2, 3, 4, 5 numbers, and so there is, since it's an odd number of them, there is a distinct middle one, and it's this one. So this would be the first quartile number, 86. And on the other side, same idea. We have 5 numbers. The one right in the middle is 96, and this then would be the third quartile number. Now this median, we usually, if we're talking about the median, we don't talk about it as the second quartile. It is the second quartile, but we don't talk about it that way generally. We just say that it is the median. Now, there is a another buzzword here or another idea. It's interquartile range. Interquartile range, and it's nothing more than the range of values that fall in the middle half of the data set. And the middle half would be this half. It would be the part of the data set that is between Q1 and Q3. And to calculate the interquartile range, you take the third quartile number and subtract the first quartile number. In this case, it would be 96 minus 86, so it would be 10. And this is telling us that the range of values in the data set is 10 in this interquartile range, in the half that is in the middle of the data set. A box and whisker plot is a rather interesting way to illustrate information in a data set. And in order to construct a box and whisker plot, we need this information. We need the lowest value, we need the first quartile number, we need the median or the second quartile number, we need the third quartile number, and we need the highest value. And with these values within the data set, we set up a diagram that looks like this. This is a box and whisker plot. And this one is very symmetric and so forth. All of these aspects that you see here can be skewed. That is, the box can be extended more this way, elongated. The whiskers might be very short or very long. You see, box and whisker plot. Okay, the lowest value goes in this position. The Q1 value goes in this position. The first quartile number goes here. This is sometimes called a lower hinge. And median value goes wherever it fits in between here, but it would be in this relative position. Then the third quartile number occurs, and this would be an upper hinge. And then the whisker goes out to the highest value. Now this box and whisker plot, also sometimes called a box plot, can occur vertically. That is, I have written this horizontally. It can occur vertically, where the highest value would be on top, the lowest value on bottom, and so on. And the box would kind of be elongated this way, presumably. Well, let's get some experience looking at one of these. We can make a box plot or a box and whisker plot either by hand, or we can use the computer. We're going to, or the calculator. We're going to do it both ways. Using the information that we had just a moment ago with that little array of 10 numbers, we can make the plot like this. You begin by making a number line. Now, my number line contains values from 82 to 102. The smallest value in the data set, recall, was 84. So here's the position of 84. I might begin by identifying this point. Let me come down just a little bit. I want to be as accurate as I can, but I want to make a nice big box at the same time. The next value, the first quartile number, was 86, and that's here. And that's the position then where the box actually starts. So we have a whisker that goes to that position, and now the box goes out this way, and it extends all the way to the upper hinge, which was at the third quartile number, which was at 96. So here's 96. All right, so that's where we'll have a third quartile value, and it'll look something like this. So here's the, good. And now we'll identify the median. The median was at 89, and here's 89. So there's the median. And the highest value was 100. So here's 100. And here's the box and whisker plot. You notice that in making a plot like this, it's pretty easy to identify the interquartile range. That interquartile range is in this region of the box plot, you see. So it is from Q1 to Q3, and that's the range. So we can easily make the calculation sort of visually here if we want to do that. That's one of the advantages of the box and whisker plot. It also tells us some things about extreme values and how information in the data set is nested. If we have a very small portion right here, then there are a lot of data values that are in that portion, in this little small range you see. And if we have a wider piece of a box or a wide whisker, then we know that we have a lot of values or a wide range of values within that region. Box and whisker plots are particularly easy on the calculator, as you might imagine. It's a matter of entering the information first, and that's pressing Stat and then Enter here at Edit, and then putting the information into some list. Now, I have placed the information already into L1, and all 10 of the items that we looked at earlier are right here. And now it's a matter of telling the calculator that we want a box and whisker plot. And we do that by virtue of the second function on the y equals button. So I'm pressing second, y equals, and I want to turn on a plot. I'm pressing Enter here, and now notice that the highlight is on off. That is, the off is highlighted. The blinking icon is on. So I'll press Enter here with the blinking on, and now the on is highlighted. So I'm turning this on. I want to select the type of plot that I want, and it's this type of plot. So I'm pressing Enter here once I've highlighted it. Now notice that the list that I'm taking information from, or that the calculator is taking information from, is L1. If the information was in a different list, we would have to punch in a different list here. The frequency for those items is 1. And the mark really doesn't make too much difference here. Well, to see the graph, we can easily set up the window by going Zoom and then cursor down to item number 9, Zoom Stat. It just is telling the calculator, it says, calculator, go ahead and you set the window up for us according to the information that's given, and then press Enter, and here is the plot. Well, the plot is as we would expect it to look. What's interesting about this is when we press Trace, we can access all of the information that we looked at before. Incidentally, up here, the P1L1 means plot number 1 taken from list number 1, plot 1, list 1. Now, with the highlight here, we're talking about a median of 89 as we found before. Cursoring to the left, the first quartile number is 86, the minimum X value was 84, and cursoring over to the right, third quartile number is 96, and the maximum X value is 100. And the interesting thing about this kind of plot is that we understand that the numbers that are on this side of our median are kind of nested close together. They have a relatively narrow range, whereas the ones over here have a wider range. And if these whiskers, if either one of the whiskers was extremely long, we would be able to tell if we had an extreme value. In fact, why don't we set up an extreme value here, and let me show you what I'm talking about. I'll press Stat and then Edit. And now let's cursor down to the last item, the 100, and enter something like, oh, maybe 111, and press Enter. And now zoom, and I want item number 9. I can either press number 9 or I can cursor down to it and press Enter. And now here is the new graph. Now, and notice how long the whisker is. The whisker is now telling us that we have an extreme value because the whisker is extremely long.